There are unknowns in every aquarium. There are variations. A fish, by and large, does not age. Either it or its eggs or its babies, when they hatch, are eaten by other parasites, the types of parasites that eat parasites.
Well, hello. Come right on in. You're at Father Fish.
There are unknowns in every aquarium. There are variations in the condition of the water from region to region, area to area, municipality to municipality, water table to water table. One water table may contain very high levels of iron, others very low levels of iron. It depends on what's in the ground and what that water is running through. Carbonates is another example. It could be very hard carbonates in one place, very light carbonates in another. Then when you get into the rare metals and rare minerals, it's even more extraneous. There are clearly fish that will not survive in my tanks. I've tried them over and over, and it's not pH and it's not temperature. It's the condition of the water. They simply will not tolerate this water. I can put them in it straight out of the tap, minus the chlorine, which I don't have here, and oxygenated. They will not tolerate it. They may last a week, 2 weeks, a month, 2 months, but eventually they fade away. They don't have longevity in that environment. And that's true of every single aquarium out there. Now, it's less true of large cichlids, of bigger fish, which tend to be more tolerant. Small fish are less tolerant of changes or of variations in the environment they've come out of versus the environment they've gone into. So any notion that you can keep a given species of fish no matter what just isn't true. Your water, your conditions, your circumstances, the light, the air, the everything in your environment are going to be unique and may preclude the possibility of certain species being able to survive with any length of time in your environment. They may do fine for a day, a week, a month, 2 months, 6 months, but eventually they're going to fade and die. A perfect example of this is the licorice and chocolate gouramis, the saltwater gouramis. Many of them now are being bred in captivity, which means they are less susceptible to the vagaries of pH. Nevertheless, there are tanks in which they will not survive. 6.0, they will not survive. It's never one little thing. My belief is it's a combination of chemicals that need to be in balance with the fish. Now, here's the thing about that. The water will adapt to the fish. It will actually assimilate certain biochemical and electrochemical properties of the fish in order to make it blend in with the fish. So it's a mutual kind of relationship that occurs, particularly in a tank where a fish is extremely well established. The water is in balance with the fish. That's something we know, in fact, nothing about. We know it exists. There's been sufficient research to determine that that condition actually exists. We do not know how to duplicate it. We do not know how to create it. We can't even replicate it given the impulses that it puts off. We know it's true. So we know there is that distinction, that refinement, that condition in which water and the fish become unified in some very fundamental way that makes the environment uniquely supportive of that species of fish, and for that matter, those species of fish that are in that environment. Beyond that, it just really requires a great deal more research, a great deal more effort to try to determine what in fact the nature of this is. There have been a number of luminaries in the field that have come to that conclusion independently of each other, that in point of fact, the water does change to suit the needs of the individual species living in it. It's very clear to me that this tank meets the criterion for that condition. This tank has been set up in its current configuration for a good 15 years. It has had some water changes, but frankly, not for about a year and a half. And even then, the substrate and the base water remained the same. So that while there were some changes, they were not total changes. And as you can see, the fish are remarkably healthy. And they've been in here, some of them, for 10 years or more. There's something else in here I want to try to show you. There are some bluefin killies in here that have white spots on them. There's one, maybe two, that have two white spots on the port side. There's one right there. See that white spot? That white spot has been on him for at least 6 months. It doesn't change, doesn't get better, doesn't get worse. No other fish has them. As I say, they've been in here for 6 months. I have run across this before, and in my research determined it is a virus. It's a relatively permanent fixture on the fish. It doesn't come and go. It establishes itself and it stays there. It does not grow into the body of the fish. It is superficial. It can be removed. You can take it off with a pair of tweezers or scrape it with a knife. It can be removed. I haven't taken these out of here because I really wanted to observe it long term. If you see a large white spot, do not assume it's anything that you need to do anything about until it becomes 2 or 3 or 4 or more spots. Then you have to do something about it. But one spot on one fish is not cause for concern. It is cause for being alert, for paying attention, for noticing it. And action is never a good idea at that specific point in time. You need first to know what you're dealing with. It may be nothing. It may be a wound, a scar. It may be a tiny worm parasite or a gill fluke that could simply attach and then unattach and be gone. In a tank such as this one that has a food web and a deep substrate, the likelihood of any parasite being able to multiply there and achieve sufficient numbers to become a problem in the tank is virtually zero. And that is to say, in nature, in a natural environment, it is rare to the point of never occurring that it, for example, becomes sufficiently viral that it kills a population of fish. That virtually never happens. And the reason is when the parasite drops off and goes down into the substrate, either it or its eggs or its babies when they hatch are eaten by other parasites. The types of parasites that eat parasites, or for that matter, eat other microfauna. Most parasites eat microfauna. There are very few that attach themselves to macrofauna such as fish or snails or whatever. Not to say they don't exist, they clearly do. Unfortunately, an aquarium that is being maintained as a clean aquarium with little or no life in it other than the fish themselves and whatever nitrifying bacteria is allowed to grow in there, but no microfauna to speak of. That tank, given the incident of a single ick parasite, will in a matter of 2 days multiply into 140, and in 2 to 3 more days multiply into 140 times 140. That's why we get infestations of ick in clean, otherwise healthy aquariums, because they do not contain the microbiota sufficient to be able to naturally control that parasite. In nature, that is the nature of the microfauna system, of the food web, if you will. It controls the explosion of a given species populating beyond the point where anything much else can survive. A sterile environment is hostile to sustaining life. So the reality is that our fish absolutely require microfauna in order to be healthy. Not only do they feed on it, they depend on it for the purity of their own environment. They depend on it for keeping waste cleared and clean. They depend on it for the balance in the system. They depend absolutely on a widely diverse food web in order to be healthy. Now, you may believe that you have a discus in a sterile environment that you purge and clean faithfully every week. But I'm here to tell you that you can try to keep that fish in that sterile environment indefinitely, but at some point in time, you will fail. And it may only be a single moment that you fail. And in that moment, pathogens will become involved in that tank and will kill those fish. It happens absolutely 100% of the time. It is why most fish die. A fish, by and large, does not age. It does not have an aging gene. It dies from disease, from predation, from injury, from starvation, and from poor quality or other problems with the water involvement. Those 5 reasons are the reasons that fish die. They don't die because they become old. Fish do not become old. There are fish, documented fish, eels for example, well over 100 years old. There are sharks, cold water sharks, documented upwards of 500 years old. Fish will live indefinitely until something happens to them or to their environment that will cause them to die. That is true in your fish tank. The fish die because something went wrong, or maybe something did not go right, that there was something wrong with the environment or some effect on the fish that caused it to die. There's a caveat, of course. There are genetic conditions, and we see this in hybridized fish. A good example are the glowfish. The original glowfish has been spawned from a very, very tiny genetic sample that was repeated over and over and over and over, literally thousands of times, and as a result has built in for one condition, a condition called bent spine that shows up after about 8 or 9 months in the fish, in which its spine literally begins to curve. And it reaches the point where it can no longer survive. That curvature has become so profound that it's affecting the neural network and affecting the ability of the fish to swim and to feed, and so it dies. That's a genetic condition. It's not a natural one, certainly, but it is one that we've seen in which a fish dies by virtue of some genetic problem. Barring that, however, fish don't die because they get old and tired. They die because something is wrong. What that means is that you can protect your fish by providing a very rich, diverse environment for them. And the more diverse, the better. The people who disclaim doing this are the people who are operating out of a sense of fear. They fear parasites. They fear pathogens without knowing what a parasite really is and without knowing what a pathogen really is. 50% of all microfauna are parasitic. 50%. Amoeba are parasitic. Mosquito larvae are parasitic. They actually will kill Daphnia. There are other microfauna that are parasitic. Okay, so there's all that. That simply points to the necessity of creating a food web in your environment, not only to provide some food for little fish, but to provide a healthier environment for them. If you want a genuinely healthy environment, it must be a diverse environment. A very narrow environment cannot be healthy because it is too susceptible to any kind of change that will throw it way off track, that will create sick fish. There are diseases that occur in aquariums that cannot be found in natural environments. It's not that they don't exist there, they do, because they come out of there, but they are so uncommon and in such infinitesimally tiny portions that they're never found. And ick is really a perfect example. It is extremely unusual to find an ick parasite in a wild, natural environment. It happens, but it is extremely rare and only occurs if something is wrong with that environment that has broken down the microfauna to the point where it can no longer control those ick parasites as they begin to multiply. So don't try to keep all parasites out of your tank. There are parasites you very much want in your tank because they will keep your tank healthy. All right.